My name is Aaron Smith, and I'm joined as always by Nancy Bakeman. This is the EBA webinar podcast series. We're really pleased to have Matt Evans with Newport Partners joining us today to talk about heating and cooling innovations for decarbonization with a specific focus on air source heat pumps. Matt, it's always great to have you with us. And I know you're going to be off camera today, so you guys won't see Matt. He's feeling a little, or he's looking a little bit rough with a cold, but that shouldn't impact the awesomeness of his presentation. It can still speak just fine. So we'll put questions in the Q&A, or you can put those in the chat. I'll present those to Matt throughout. Otherwise, we'll have some time at the end to ask additional questions. So thanks everyone for joining us. And Matt, we'll turn it over to you.
Cool. Thank you. Appreciate it. Welcome everybody to this afternoon's course, Heating and Cooling Innovations for Decarbonization. I'm Matt Evans with Newport Partners and Ventures. Quick rundown, my background in history, building systems analyst, certified HERS rater, been involved in the construction world since my high school years, starting with a construction company in 9th grade. Stayed with them for several years. I went to college and everything. I've been with Newport now. I'm actually moving into my 17th year with Newport. I do a lot with residential and commercial buildings, above code design, advanced building designs, energy codes, consulting work, building science, you name it. I've been involved with it. I've done trainings across the country. Most of them focused here in the Northeast where I am in New York State, but I've done trainings throughout the country. I help to support a lot of research projects. One that I'll briefly talk about in today's class, we did this past 2 years. This past winter, we just finished up collecting research on a cold climate heat pump here in New York State. So I'll tell you a little bit about that project when we go through the training today. Previously, prior to coming to Newport, I was a secondary level school teacher, teaching technology education programs and doing building trades programs at a vocational education high school down by New York City. Master's degree in curriculum development from University of Albany, bachelor's degree in vocational education from Oswego University up near Lake Ontario, and an associate's degree in building trades from SUNY Delhi. So I want to welcome everyone. Today we'll be covering kind of where we're headed and where multiple states are headed with respect to decarbonization and the use of heat pump technology. There's been a lot of advancements. If you tried out heat pumps even just 5 years ago and you had issues with them, especially in colder climates, go revisit the topic, go revisit the products available. The technology has advanced rapidly. I just sat in on a course yesterday with manufacturers from across the world that are doing a lot of research and developing new products with heat pump technology for heating and cold climates, mild climates. They're even talking about making an all-in-one heat pump system that will not only heat and cool your home, but will also include your hot water. So there's some really cool advancements. That's air source technology. Geothermal is a whole nother topic. Ground source heat pump technology, that's a whole different topic. We're going to mainly focus on air source technology today. So we'll go through several things, where energy codes are, where they're headed. I only have an hour, so there's a lot to get through. We'll look at air source heat pump technologies, some terminologies that have been changing, and then I have several examples of successful projects. Majority of them, I believe, are all based in New York, which is a good thing because we're in a cold climate zone. We have 3 climate zones here in New York, climate zone 4, 5, and 6. And 5 and 6, we get good cold winters. We get a lot of snow depending on where you are in the state. So to see these heat pump technologies working in cold climates is phenomenal. 10 years ago, you wouldn't have heard me saying that at all. They've definitely had a lot of advancements in the technologies with air source heat pumps for the colder climates. So real quick, We have a lot of options for heating our homes, newly built homes, commercial residential buildings. The technologies we use have gotten much more energy efficient over the years. We started out, people still use non-condensing furnaces. The minimum standard is 80% right now. Contractors by me, it's not, it's more likely that they'll be putting in a 95 or 96% AFUE gas furnace. uh, those technologies have advanced quite well, and that's commonplace now. But now here in New York, we're looking at actually switching over to heat pump technology, ground source or air source, because of laws and regulations coming into play in the next few years. So we're going to talk about technologies advancements here, AFUE heating, furnaces, boilers, water heaters, HSPF, the heating seasonal performance factor for heat pumps. That's a standard term you'll hear when we're talking about heat pump technology. And then SEER, when you get into cooling, seasonal energy efficiency ratio. That's your cooling output. There's inputs, outputs, sizing of these systems are very important. So there's a lot of things to consider. Manual J reports are very, very important when you're dealing with heat pump technology. You really have to focus on a good manual J report to make sure that's done properly. I've seen contractors, I've done a lot of Energy Star homes over the years. I've seen years ago contractors reusing the same manual J reports for all their homes, and you can't
What?
do that. You have to be able to switch and dial in each home independently. So it's amazing what we've seen in the past and what we're seeing nowadays. So real quick, through the years, the technologies have improved with air conditioning. Now we're talking about heat pump technology. Air conditioners on the market today can range from 13 to 25 SEER. The average central air conditioning unit sold today has a SEER rating between 15 and 18. Back in 1992, we were looking at 9 and 10 SEER for units, and those have been replaced and pretty much put on the back burner now. You can't get anywhere nowadays unless you have basically a 14 SEER and up. And the HSPF levels have increased as well. The higher the number, the better for efficiencies. So the technologies have improved a lot. And the numbers you're seeing on your screen here, I have contractors. This is the minimum requirement. I have contractors that are going well into the 20s for some of these numbers. Yeah, the systems are going to cost more. Those are all things you have to weigh when you're doing new construction or when you're replacing equipment. There are ways to do these calculations, return on investment, payback periods. So those are all things you're going to want to consider when you get into these technologies. Federal standards are something that the codes look at. I have the last two, well, depending on where you are in the country, I have the last two code cycles up on the screen here. The 2018 IECC, which we're currently under here in New York State, and then several states have started to adopt and have already adopted the 2021 IECC. And in New York, we're going to be adopting the 2024 energy codes in 2025. So new standards for air conditioners and air source heat pump technologies did go into effect this year, January 1st, 2023. And now you're starting to see terms like SEER 2 and HSPF2. There's been changes to the formulas and how they measure the efficiencies of the heat pumps that are in use today. So you're going to start to see more and more labels. If you haven't already seen them, SEER2 and HSPF2. In our modeling software that we use, we have a lot of changes we have to make into our software inputs for when we're modeling homes. Myself as a HERS rater, the neat thing about modeling a home before it's ever even built is we can put in all the different systems in the house, different heat pump technologies. If we want to do a heat pump water heater, Whatever we're doing with the home, we can build the envelope in the software, and then we can put in the different mechanical systems. We even put in the refrigerator, the dishwasher, the washer and dryer. We put in all that information, in the reporting back from the software tells us how efficient the house will be and if it's cost effective to do it one way or the other. So it's a great way to do an educated guess on how to build the home and what systems to use. So as I said, you're going to see newer energy guides with SEER2 numbers on them, HSPF2 numbers, instead of the old rating system. So this is something to be aware of, and this did go into effect, as I said, January 1st of 2023. So codes are looking at this as well, and you'll start to see this information put into the ICC code books for the energy codes. HSPF and HSPF2 are ratings that measure the heating efficiency of heat pumps. The main difference between the two is the external pressure testing condition. HSPF rating uses a 0.1 inches of water column measurement and external pressure, where the HSPF2 uses a 0.5 inches of water column external pressure. So there's a different metric for how they're measuring the efficiencies of the system. And this new version really dials in the more exact simulation of how these units will perform, whether they be in cold climates, mild climates, warm climates, etc. Zero emissions, and why we're talking about heat pumps today. As I said earlier, there are states, California, New York, and other states will be following, that are looking to go to zero emissions for new construction. That means prohibiting fossil fuel equipment and building systems. They're looking at doing this with residential as well as commercial. For residential, basically what you'll see is space heating, water heating, cooking, clothes dryers, and fireplaces not being allowed to use gas, natural gas, or propane. We have systems in place that can still be used to heat our home, to water heat, cooking, etc. We have the electricity to do that. We have the products to do that. I have a client that I work with, a builder. He's been doing all electric homes for over a decade and a half. His homes, believe it or not, are all net zero in many cases. So this is something that's been done, is being done, and a lot of contractors are going to have to switch over to it. And there are things to look at, safety wise, costs. There will be hiccups along the way. It's not going to be an easy transition, but there's a lot of support out there to make this transition and to talk about what will work and what won't work. Here in New York, the zero emissions new construction that we're looking at getting into, it will not apply to outdoor gas grills, wood burning equipment, renewable natural gas, clean hydrogen, if you have that available. So every state's going to be a bit different. How do they plan on getting this done? Most likely here in New York State, we're going to adopt all of this with our next energy code cycle coming into play in 2025. California is doing it their way, and other states and cities and towns, they might be proactive and do it on their own. I know I worked with several communities across New York looking at adopting all electric energy codes within the last 2 years before the state even was making the decision on it. So there's going to be some changes coming up, and it's all related to reducing greenhouse gases and really working on and making a significant jump and doing something with our climate and making a difference there. So air source heat pump technology, let's take a look at heating and cooling statistics and where we're at today and where we're headed in the future. As you can see on this chart, most natural gas that is consumed in the United States is used for heating. And you'll see here in the red, most of it is natural gas. And you will see natural gas also is a large consumer for water heating for residential homes as well. Electricity, not so much. There's additional costs with electricity. But if you think back in the 1970s and 80s, you were seeing a lot of homes going up that were using just baseboard electric heaters. Now we've moved away from that. You can still use it, but the heat pump technology is 3 to 4 times more energy efficient than just baseboard heat. That's 1 per 1 element for input and output, where a heat pump, for every one element of electricity you put in, you're going to get 4 to 5 times back in heating energy or cooling energy with heat pump technology. And you can see other fuels being used: fuel oil, kerosene, propane as well. But natural gas is the big one for heating our homes that we look at. Uh, Building type makes a difference on what fuel will be used. For single family buildings, natural gas is the large dominant fuel choice. Apartment buildings, it starts to go down 2 to 4 units, and it gets smaller as you get into larger apartment buildings. They tend to transfer over to electricity as the top choice. And you can see that even in apartments, 2 to 4 units is relatively large for all electric. And a manufactured home, very common to have that as all electric as well. So these all electric building structures, they're out there. We've been doing it. The change has to be made locally or statewide. The technologies are there, and we'll talk about those technologies coming up. I have several examples of buildings that are using them. Location does matter when it comes to transferring over to all electric. You'll notice as time goes on, the more dominant locations using electricity for heating are the warmer climate zones, the southern states, the western states. Up in the north areas, the colder climates, the transition hasn't been as quick, but it is happening. And you can see here across the Northeast, we're getting into the 20 and 30% range. And you'll see changes with this as time goes on, as states adopt more stringent energy codes and zero emissions at new construction builds. So there is and has been a steady change. The training I was in on yesterday was even talking about um, colder countries where they have heat pump technology in 40 to 50% of their buildings in colder climate zones than what we have here in the US. Is air source heat pump technology expensive? Yeah, it can be. And I'm not going to sugarcoat it. There are costs attached to doing this transition, but proper planning is going to reduce the costs, and better energy codes that we have in place now, you have to realize, means that you can reduce the size of your heating and cooling systems in your home. For example, in my house, I have a house that was built in 1997. Um, the original gas furnace for that home was 108,000 BTUs. When I had that gas furnace replaced, I had a 88,000 BTU, 96% AFUE gas furnace installed. And this past winter, we installed a cold climate heat pump, which was 3 tons, 36,000 BTU. And believe it or not, that heat pump unit kept my home at 68 degrees all winter long. I'm in climate zone 5 in upstate New York, and we had that heat pump running at 68 degrees inside my house. Thermostat was set at that number. We didn't change it. And when we got down to temperatures below zero, we had a recorded day of -7. The heat pump heated my house to 68 degrees. No backup heat was in use. We actually had the gas furnace shut down all last winter to see what the heat pump technology could do, and it proved to work very well. Um, so you have to look at the technologies that are out there. You can see the cold climate heat pumps are going to cost more. There's low cost options, medium, high cost. For a lot of new builds, these homes that are built nowadays are built tighter, they're better insulated. So you don't have to go for all the glamour and glitz of the high end units to get the best investment. So you got to really plan ahead and take a look at all the options out there. There's several choices available nowadays. Retrofitting of existing homes, a lot of things to consider there as well. If you currently have a house that has ductwork in it, seal your ductwork up, then get the heat pump technology, get a heat pump installed, but seal up your ductwork. Make sure it's not leaky. Same thing I tell folks that look at doing solar on their house. Solar panels can be great, but make sure the company you're working with does an energy audit on your home and makes you make an investment in doing a changeover in your lighting. Go to LED lights, do Energy Star appliances, make efforts in your own house to make it as energy efficient as possible, then put in those newer systems to really take advantage of everything. um, there's different financing and incentives out there. One website I like to share with everyone, and you can take a look at it. I'm not sure if I have it linked on this presentation, but the website is called Desire, DSIRE. You can just go to Google, type in DSIRE, and it'll actually show all 50 United States, and you can click on your own individual state, and it will show you some incentives that are available out there. You also have options like Green Choice from Freddie Mac, National Grid, or whoever your utility company may be. Take a look to see what your utility company is offering. We have National Grid here in New York, RG&E, Rochester Gas and Electric over in Western New York. That's just here in New York. Take a look at your utility companies for incentives and financing options. Flex tech programs, federal tax credits, you'll find them on the Desire website, DSIRE, and many more options available. Some of these Green Choice Awards, for example, can help pay for upgrades to existing homes. One of the options they have right now is they'll cover up to 15% of the home's appraised value, and they'll help cover improvements of over $6,500, which you might have to get an energy report from a HERS rater like myself to be able to show what improvements you're going to make. But then you can get financing available to you, low cost financing to make those improvements on your existing homes. And that's going beyond new construction homes. Heat pump sales in New York State, believe it or not, passed gas furnaces in 2022. Heat pump sales across the country are above gas furnace sales. First time ever in 2022. And you can see this chart. It starts out at 2012, so a decade ago, and you can see a steady climb. We had a steady climb of gas furnaces, and the heat pumps were climbing just as much, and now they've surpassed, which is pretty cool. As energy code evolves, states adopt newer requirements, and this is one of the reasons we're seeing a sharper increase with heat pump technology and heat pump installations across the United States. So, a little bit on the history of heat pumps and where we're at. This is just generic. I can go through these slides pretty quick here. But late 1800s, natural ice shortage led to the development of refrigeration, basic principles on compression and absorption. 1920 to the 1950s, reverse refrigeration cycle to make heat. Further development of compression technology. 1930, house in Tucson equipped with a heat pump. 1932. Southern California Edison Company. They had a system that was 10% efficiency. We've been growing steadily since then. Chicago's World Fair, 1933. They introduced air conditioning there. 1947, early boom in demand for unitary window air conditioners. 1948, New York City, 14 floors had heat pumps installed for heating and cooling. 1950s and 60s, oil prices fall continuously, dramatically slowing down any advancements in activities with our technologies, which was a big mistake. I think we should have kept advancing technologies. So there was a slowdown there. But then the 1970s hit, and we had the OPEC. We had the oil embargo, OPEC, all that stuff going on, the longer lines, oil prices gone up over 300%. We see the resurgence of heat pump technology. 1976, 1.6 million unitary heat pumps for cooling and heating were operating in the USA. 1979, we had a second oil crisis. Rapid growth of the heat pump business grew faster than the technology. Too many competitors with not enough know-how. And I'm glad to say that the training I sat through yesterday, there was 4 different competing heat pump companies all on the same call together, all sharing information and talking together. So it's really cool to see the advancements that we have today than what we had in the past. Then in the 80s, we had oil prices beginning to decline, and the heat pump boom kind of came to the end in the late 80s. And then in the 1990s, U.S. passes the Environmental Protection Act, promotes heat pump and other efficiency technologies. 1999, only one manufacturer of these technologies in the USA. And then by 2008, we had cheaper and more efficient vapor compression technologies that were developed. And now we're in 2023, and there's a lot of options available. And by the way, you can go on Energy Star website and look at the different heat pump technologies that are available. Look at the different manufacturers, the technologies and the systems, the advancements of them, the efficiencies. So definitely take a look at the Energy Star website and go right to heat pumps. You'll be amazed at what systems are out there. And that's also another location to find incentives for those technologies. So air source heat pump technology, basically they're taking electricity and they're using that to compress gases and having fans move gases around, moving air around. They're not using that electricity to create the heat. And that's something that a lot of folks get wrong, that the electricity is used for gas compression. The compression of the gas is what's going to get our hot air or cold air. And these systems, think about a refrigerator in your home. That refrigerator is running. It's keeping your freezer cold. It's creating your ice cubes, keeping your food cold. The output of that system is hot air. And if you reverse all that, then you get cold air coming out. So like heat pump water heaters, their output is cold air. Refrigerator output is warm air. All those same systems we're using for air source heat pump technology, we can reverse the valves to heat or cool our house year round using one device to heat and cool, which is pretty darn cool. And the advancements of these gases and compression levels has come a long ways in a very short time. Heat pumps can have an efficiency greater than 100%. If you remember a few slides ago, we had heat pump technology that was at 10% efficiency back in the early 1900s. We're now surpassing 100% in efficiencies when we're in heating mode, because the heat is extracted from both the work put in and the heat drawn out of the environment, even if it's cold outside. Remember, I said my house is using a cold climate heat pump this past winter, and at -7 degrees, that heat pump was still finding air outside that was warm enough to get those gases to get me hot or warm air inside the home. But temperature outside does make a difference for efficiency. The colder it gets, the efficiencies will drop off, and you may have to look at getting into backup heating systems, electric heating, or in my case, my house is set up as a dual fuel system where I can use my gas furnace for my backup heat, or I can set the technology, I can set up the thermostat to have the gas furnace to come on at a certain temperature. And we're actually running the math on that right now to determine what is the most cost-effective switchover temperature to go from heat pump to gas furnace. But like I said earlier, the cold climate heat pumps, they'll be able to heat your homes down to a very cold temperature, much colder than you think it could be. And that's why we have heat pumps that are deployed and being used in Alaska, and we have cold climate heat pumps being used in Maine. So when they've been proven to work in those colder places, we know that they should do fine in other areas around the country. So heat pump basics for heating mode. As pressure increases, the temperature increases, volume and amount in the tube always stay the same in this scenario. Heat pumps can have efficiencies, as I said, above 100% in this situation. Depending on the time of year, inside the house versus outside the home. Outdoor temperature raises the refrigerant temperature enough to vaporize it, and then it comes inside and we pull that heat from that compressed air fluids there. And then we reverse it in the cooling mode. So these valves go back and forth depending on time of year. So you feel this when you're standing, as I said, next to your refrigerator. You can feel that hot air coming off your refrigerator. If you're ever standing outside by a house with a heat pump unit, you can feel either the hot air or the cold air coming off of it, depending on time of year. So this is all happening with the brains, the inside mechanisms controlling the heat pump technology. All you have to do as a homeowner is just go to your thermostat and put it into heating and cooling mode, or set it to auto, and the thermostat will do it on its own depending on what the temperatures are. Then you can tell the thermostat, what do I want to heat or cool my house to? You don't have to do anything else. It figures it all out for you. The gases that are used, we are changing the gases. Heat pumps are good for decarbonization. That we're only using electricity at a house, so there's no gas emissions at a home. The refrigerants, however, can still be damaging to the environment. New refrigerants are being studied all the time. We're hoping to find ones that have a low global warming potential attached to them. Best options are naturally occurring, but they have some operational problems. The four most common natural low uh, global warming potential refrigerants, GWPs, struggle with flammability, toxicity, and high operating pressures. Um, so what you're seeing now is an R410 is a very common refrigerant that's being used, but its global warming potential is a big concern. So we want to reduce that down. So there's other products that are available on the market, but then you'll see their settings, their pressures get much higher. And I heard some talk of these installers having to test their systems up to 600 psi for these newer products, and I don't have that one on this list. But you can see where naturally occurring products that might work very well, there's an issue with toxic or high flammability rates. So that's a concern as well. So I'm sure they'll settle upon refrigerants in the future that'll be might not be the best for one thing, but better for the others. So right now we're locked into an R410 for being the most common, and R134 is the second most common, and the R32 will be coming into play here, I think, in the next, gosh, I want to say the next year or so, year and a half, that R32 will be replacing the 410 option. So you get rid of the global warming potential, but then you're dealing with potential flammability of the product. But it's all in a self-sealed system, so safety should be not much of a concern if the system's
But
operating properly.
Matt, part of the struggle, I think, is that these systems have been in use in Asia and Europe for many, many years, but that we just have some different requirements
Oh yeah.
on it here, right?
Yeah, the one of the folks that was on the training yesterday, he's from Europe, and he was kind of laughing at what the US is doing.
Yeah.
He's saying we used I think he said they were using the R600. And
Okay.
he said the US won't even consider that. They haven't considered it. But he said
Right.
over there it's commonplace, because it's an easy gas to get a hold of, and they can use it, and it works well on their systems. So,
Yeah.
we'll see. We'll see with time what happens, what decisions are made.
Yeah. Great. Thanks.
Um, One thing I do want to point out, we've been talking about in codes now for years, energy codes, programmable thermostats, and setback requirements. Newer technologies with heat pumps, inverter driven heat pumps, they're great at maintaining temperatures. So, what you're going to see is a very strong promotion, big push for setting your thermostat and leaving it alone. And that's what we did in my house last year. We set it to 68 degrees, we left it. Uh, with older homes, gas furnaces and stuff, they always talk about your programmable thermostat, change your temperatures when you're not home, put the temperature up when you walk in the door. With the air source heat pump technology, set it and forget it. Call it a day. You're better off that way. And those of you that are used to like radiant floor heating and floor heating, you're used to the same thing. You set your temperature and just leave it alone. And you'll notice that the system will do just fine heating your house. The heat pump technology is not good at bringing temperatures up suddenly. So that's something you want to be aware of. You're not going to go away on a vacation and come home to a house and turn your thermostat up on your smartphone while you're driving back from the airport. It's going to take a while for your home to get heated up again. So set it and forget it. So it'll be a change in the mindset for folks that have heat pumps in their homes. Here we have different types of air source heat pumps that are available. In the state of Maine, they did a 2020 climate action plan. They set a target for 245,000 homes. That's 48% of their housing stock. They plan on having 48% of their homes uh, with heat pumps installed by the year 2030. So they have a decade to do so. We're already going into our third, fourth year with Maine doing that climate action plan. So they're going to be doing that in Maine. They've already started it. Massachusetts, they ran a Global Warming Solutions Act they put into place, and they're looking at getting 40%, 1 million homes, 40% of their housing stocks transitioned over to heat pumps by the year 2030. And then there's the 2050 decarbonization roadmap, which is setting up other targets as well. So you're starting to see stuff that we were talking about 10 years ago, 15 years ago coming into play now, and dates coming up. 2030 is not that far away. Couple 2 months from now, we'll only be 6 years away from that. Colorado in 2020 did a greenhouse gas pollution reduction target of 60% of the market share. 60% of the homes need to be switched over for heat pumps by the year 2030. So there's a lot of things going on in several different states. So technology wise, you have central air source heat pumps, split systems, variable capacity, variable refrigerants, cold climates, dual fuel technology, mini splits. probably hearing mostly about mini splits with heat pump technology, especially in existing homes. Uh, they have window units. They're starting to do this now down in New York City, where you can basically plug in a heat pump technology and set it into your window, and it saddles it so the window doesn't have to be open so far. So that's a retrofit of existing buildings for like apartments and whatnot. And then you get into ERV units, energy recovery ventilation systems that also help to condition spaces, and PTAC units. And PTAC units, think of your hotel where they have that little heating and cooling unit below your window. And that's basically the PTAC units that you would see. Here I have a couple of photos. This is actually, gosh, this is going back maybe 4 years ago, 5 years ago. This was a home, an all electric home built in upstate New York. I was the raider on this house, and they did it all electric, brand new build, full basement, 1.5 story house. I say 1.5 story. The whole first floor was done, and then part of the upper level was finished off. But this particular house, this is the outdoor unit. You'll notice it's up on a stand to keep it away from the snow. But this unit here was heating the entire house, going to the basement. There's an A coil on top of the blower motor, and that blows either hot air or cooled air throughout the entire duct work of the home, heating this house or cooling the house year round. In this particular home, they added solar panels to it. Last time I checked in with the homeowner, they had no electric bill. Their solar panels were covering all the costs for heating and cooling the home. So a lot of cool technologies you can get involved with, and getting away from utility bills or reducing them drastically if you implement systems like solar on a house. Um, Most air source heat pumps are split systems. You have a unit inside the house and a unit outside of the house. You also can get into the PTAC units where it's through the wall if you want to do that. They're typically a smaller system, variable refrigerant flows. You have central systems, backup electric resistance heat tied into those. Mini splits, you can run those line sets to different rooms, but that can start to add up quickly, especially on retrofit projects. So you have to really plan out how you want to deploy heat pump technology in either a new build or an existing home. I think for new construction, it's a no-brainer and can be done quite cost effectively. But mini splits, they can be retrofitted into homes, especially if there's no ductwork in the house. You can install these, and one of the benefits of a mini split system is you only have to heat or cool the room that you're in. So if there's parts of the house you're not in, you can shut the system down or lower the temperatures on it. But they all have independent controls. You can get mini splits that will mount in the ceiling, up out of the way, out of sight, out of mind, wall mounted units, and then you can get ducted systems with mini splits as well. So there's a lot of options available when we get into heat pump technology. So you'll see this one outdoor unit is actually able to run to a mini split on the wall. It's able to run to a ceiling mounted unit, and then it can run to a ducted unit up in the attic as well, or wherever you install this. So there's a lot of flexibility attached to these systems. You can increase the size and usage of them as needed. Other examples, variable refrigerants. Now, guess what you can do? You can be in a building, you can be in your house, you can be in a business, you can be in a restaurant, whatever you think of here. You can have an outdoor unit that will allow you to cool, heat the building, different locations, heating and cooling can be active, or you can have the system shut off. So this gives you a great option as well. So variable refrigerants, multiple zones, different temperature settings. Um, think about your car nowadays. They have climate controls in your car, driver's side, passenger side, rear or back of the car, all different heating and cooling zones. that are occurring. We can do this with our buildings nowadays. So heat pump technology, the VRF, variable refrigerant systems, can condition, heat, and cool at the same time. So that's a pretty sophisticated control system that you get involved with, but it does work and it is available. So something to consider, and this could be a huge sell for uh, homeowners that have different needs within their homes. The ERV systems, you probably have heard of HRVs, heat recovery ventilators. We have ERVs, energy recovery ventilators. Getting those systems to also do heat pump technology, getting heated or cooled air pushed through the home, filtered, cleaned air, fresh outdoor air coming in, stale air, moist air being pulled out of the home. So conditioning ERVs is a really good choice to look at, especially since newer homes these days are built very tightly, and we have to do whole house mechanical ventilation. Majority of energy codes call for whole house mechanical ventilation when we get below 5 air changes per hour. Some states are down to 3 air changes per hour for the blower door test results. Here in New York, we have to be at or below 3. So whole house mechanical ventilation becomes necessary to do. So incorporating ventilation with the heat pump technology, that's another great option that's available. Here's our PTAC units, something you'd see in a hotel room, for example. This little guy here, this is the U saddle control. This is a retrofit in an apartment building. This unit saddles over the openings of the window. So a majority of the window can be closed. The bulk of this unit is outside the window, so you don't have to hear it. You don't have to see it, doesn't take up space. And then you have the indoor unit that sits inside the window that's going to blow that heated or cooled air across your room. So there's a lot of cool technologies that are available. And wintertime, we have pressure increases, temperature increases with fluids that we're using. I think I had this slide up earlier, so I'm going to skip this one because I think we doubled the slide somehow on this. So I'm going to skip that one. But I wanted to point out all these new technologies, advancements with older technologies. We still run into issues. We still have problems. Builders have had bad experiences with them. Clients have had bad experiences. Testing standards might not match up to what the systems can do. Lower efficiencies, compressor limitations, what refrigerant was selected, what's being used, and getting frozen coils. This is less likely to happen with a proper plan and use of the system. So you'll notice this one is blowing the air up. Most, if not all, newer heat pump technologies are going with the horizontal blower. This has been a system, variable speed compressors. This is a system that has been worked on and has become the dominant choice now. So instead of blowing upwards, it's going to blow sideways. Cold climate heat pumps can reduce household energy consumption by up to 40% in homes that are currently utilizing electric resistance baseboard heat. So that's a pretty substantial decrease there. Air source heat pumps can be installed in all types of homes and multifamily buildings. They're easy to retrofit in. There's costs associated with it. Technology for the air source heat pumps has become much better as the equipment now performs very well in extreme conditions. Several of the air source heat pump components have been improved. The coil design, the motors are more efficient, the variable speed compressors, they automatically adjust speed and energy consumption when temperatures change. So it's not either on full blast or off, it's on, but then changing the energy use depending on what the temperature settings are, what the outdoor temperature is. Thermostatic expansion valves. This enables a more precise refrigerant flow control for the indoor coil. The variable speed blower motors, they have boosted their efficiency. So there's a lot of advancements that have taken place in the last 5-10 years. Variable capacity. Department of Energy has several studies out with respect to variable capacity. You can find them online. The VRS, variable refrigerant flow systems, can act as a multi-split system. As I showed on an earlier slide, it will connect multiple indoor units with one centralized outdoor unit, allowing you to do the heating and cooling, etc. So there's a lot of flexibility with these systems. The dual fuel, this is what I have installed in my house. For a majority of the heating season coming up, we'll be using the heat pump to heat my home, but we'll set the thermostat to a certain temperature to have the heat pump switch over to the gas furnace to use the gas. Since I have a relatively new gas furnace that's high efficiency, we'll use that as a backup heat source, especially when we get long extended cold spells. But I can envision my heat pump, a cold climate heat pump, being used for a majority of the winter.
Hey, Matt,
Which will, yes.
one of the questions that we had come in, I think, is really similar to the unit that you have in your house. Green Rita has a Goodman Daikin unit, and it looks like it is a hybrid unit, and is wondering how to perhaps drive that entirely by electricity. And I believe the answer is that you can set it in a heat pump only mode, as you did this past winter. Can you just talk about how to do that for them?
Yeah, depending on, we'll call it the brains of the system. The unit I have is a newer unit where the brains of the unit don't allow you to actually shut off the gas furnace. It makes its own decision. You can't actually shut it off. We had to go in through programming and what we call a dongle to go in and force it to turn off the gas furnace.
Mm-hmm.
But for a lot of thermostats and a lot of manufacturers, you can set it up where the heat pump only mode
Yeah.
or gas and heat pump mode or off. So you have those options built in. The
Right.
system I have installed is a more advanced system where they're trying to use, let's call it AI, artificial intelligence, to make an educated guess on where it's most cost effective to switch between the two, which is, I think, a technology you'll start to see more of. The research we did was actually looking at having the device go out real time to your electric company and your gas
Right.
company to see what their fuel costs are. And
Mm-hmm.
it will decide, independent of the homeowner, oh, electric is cheap right now. Let's heat the home with electricity. Oh, the gas went down. Let's turn on the gas furnace and use that to heat the home. So
Right.
that'll be real time decision making. That's something you're going to start to see more of in the future as well. We'll
Yeah.
actually be looking at utility rates during the day, during the night, the evening hours, the morning hours. So it's really cool what we're getting into with the technologies nowadays.
That's great. Matt, you mentioned your hybrid study results. One of our guests is wondering if they can get a copy of your hybrid study results.
I will have my email at the end of the slideshow,
Great.
and I invite anybody to email me directly. What I can send out currently is we have a write up that's being worked on and being reviewed at the national level. So as soon as we get more information out there, we can start to send stuff out to folks. But if they email me directly, I'll see what I can get them currently that's available before the final research paper is published.
And Matt, the another question, as long as we're on yours, is what brand did you use in your house?
Let's see.
Maybe you don't have to say if
Let's
you don't want
let's
to.
let's see. I think I have pictures of my house on the slideshow.
So you just have to
So
infer it from the picture.
So let's see if there's a picture that might show that.
Okay.
I don't know if I'm in a position to promote or say one manufacturer over another. I try not to. So we'll see if depending on what pictures I have, if you can figure it out. But maybe privately, if someone emails me, I could privately share that information with them.
Well,
I'll have to see. I
I
don't know
think
where my non-disclosure agreement's at with
yes,
that.
but I think the big picture piece of it, Matt, and see if you agree with me on it, is that there are a lot of good ones coming onto the marketplace every day,
Oh yeah,
from a lot of different manufacturers. And I think as long as people pay attention to the SEER 2 or HSPF2
yeah.
requirements, and perhaps those related requirements in the Zero Energy Ready Home program or otherwise, they're going to be in pretty good shape.
Yeah, I think they'll be. And I just found out yesterday one manufacturer purchased three other companies. I wasn't even aware of it, but they're using those company names still. But there's a overall ownership, which I didn't even know about till yesterday. I was under the impression they're all independent. So it's real cool what we have there. I'm noticing time. I have about 12 slides left, so I want to shoot through these quick, and I
Sure.
can stay on a little bit after here, no problem.
Yeah, I'm
So real,
excited to hear. I'm excited to hear. I'm sorry.
yeah, I have
I'm
the case
interrupting you,
studies
but
up. No
the
problem.
air to water heat pumps are very
Yeah.
interesting for the
Uh,
radiant.
Yeah, and this is something I was introduced to years ago. A contractor down on Long Island in New York uses air to water heat pumps for heating his homes that he builds. So using the air source technology for getting radiant heating into your floor. So this is the technology that's available. And if anyone is familiar with in-floor heating, you know that your temperature settings can be much lower with radiant heating than you would have with a ducted system in a home.
Right.
We've done research on that with radiant heating before, so it's a cool technology, and they're using this to have hot water heat their floors and to have the hot water for their showers and their sinks. Um, so here's the cold climate heat pump technology challenge, sponsored by DOE. More than 20 utilities are cooperating with this and participating. State agencies have also gotten committed to the challenge as well, and they're looking at deployment and commercialization for cold climate heat pumps above and beyond what we even have by 2024. So you're going to even see more of a jump in technologies with cold climate heat pumps, because that is basically the way we're headed. Heat pump air source is going to be a cost effective solution. Ground source heat pump technology, great product, but there's an added cost to doing ground source. It might not always fit in all municipalities and locations. So the air source technology has really come a long ways. So I invite everyone, definitely check out Energy Star website. Energy Star is pushing the envelope by creating a lower temperature testing requirement. Requires testing to be done according to specific procedures instead of a number that manufacturers all get different anyways. So calculations, measurements, and estimations are all changing and becoming more accurate. That's why you have the CR2, the HPF2 now. So there's a lot going on there. I want to jump over to some of the case studies we have. Here's the dual fuel one. Um, with respect to my home, we are setting up a more advanced control scheme. Oak Ridge National Labs right now is running simulations for us. We took the test data from my home, and we now can use all the results from my house and apply it to different locations across the country with using software modeling to really give us really accurate results. Calculations, looking at economic efficiency metric to compare efficiencies with gas furnaces. It allows for the dual fuel system to choose the systems with the highest efficiency per energy costs. System controls are based on temperature and price of electricity. So here's my house. It's an old photo because we have since replaced the garage door and the shutters. But there's my old uh, standalone air conditioning unit. I believe it was a 9.8 SEER system that has been replaced with, and I'll jump ahead here, with a cold climate heat pump. There's my old system, Armstrong. I don't even think they're manufactured anymore. Someone
Yeah,
could chime in and
I don't think
correct.
so.
Yeah, I think that might have been part of Carrier at one time. I'm not sure. But what we have is a standard uh, 20, 2300, 2400 single family 2-story house, home tested out pretty well with insulation levels that were used back in 1997. So we used a typical average home, 25 years old. It was built in 97, climate zone 5. We're in the Albany, New York area. I had installed a two-stage 96% AFUE gas furnace, and my air conditioning unit was up for replacement. So instead of just swapping out the air conditioning unit with another air conditioning unit, we said, you know what? Perfect for research home. Let's do the heat pump technology. Let's see what the results we can get out of it. So this is the replacement unit raised up off the ground. It's been installed. It operated all last winter. On the back side of this wall is my furnace. So it's located point A to point B, a nice short run, basically where the air conditioning unit was. So it's really cool. The results are coming in are pretty phenomenal that we've seen so far. So you can see my old system was using the 22, and the new unit is using the refrigerant, the 410. So you can see the older, and I remember when they were removing the old unit, they had to suck out
Mhm.
all the juices from that and get them
Right.
bottled up and whatnot. Um, so that's my house. A lot of good stuff coming out of that research. Here are houses, some of them that I've been involved with as an Energy Star HERS rater, but these are homes that are all electric houses. These are homes mostly across New York State because that's where we're out of, and that's where I do my ratings. But here's an all electric home. Their average monthly energy bill is $90. They're using a heat pump in the home to heat and cool the house. Here's another one. This is down going towards New York City, but it's up in the Catskills, um, Catskill Mountain Range. This house average electric bill $10 per month. Hers is a -3. So anything below zero, you're getting money back. It's a 4,400 square foot house, 4 bedroom, 3.5 bathroom. You can see the backside. This roof is all solar panels. The entire house is heated and cooled with heat pump technology. Here we have a multi-family building in climate zone 6. This is in Ithaca, New York. Uh, Cornell College is there. Uh, this is a climate zone 6 location, south end of, I'm trying to think of what Finger Lake it's on now. I think Seneca Lake. But
Yeah,
this
Seneca.
isn't, yeah, this is an all electric apartment building. So this is pretty cool. Using heat pump technologies to heat and cool the building. They have solar on it. Nice little building there. This one here, I threw these pictures in because this building is located down the street from our offices. This is located over in Rotterdam, New York. This is a climate zone 5. These are called net zero apartments. All of their energy is produced on site. What you see here before it was all paved all the way, this is the carports. Above the carport is all of your solar panels. That's producing all of the electricity for the building. Up on the rooftop of the building, you look up here, those are the solar collectors for hot water. So all of their electric and hot water needs are met by the sun. If it's not sunny out, they produce more energy each day that the system's operating, so they get that back. Uh, it's really cool. And these are the heat pump units mounted on the backside of each apartment building. Each one of these units runs to each apartment, and in each apartment, they have two mini splits mounted. So it's a pretty cool building. This project was so successful that down the street from it, they built a whole nother set of apartment buildings. I think they put up 8 more of these larger apartment buildings that are all net zero.
Hmm.
So that's pretty impressive. All electric, all net zero. And then here's a client I work with on several homes over the years. This is a slab on grade home, single story home, slab on grade, super insulated. I'm talking R20 under the slab. They're double studded walls. They got it up to an R45 for the walls, triple pane windows. Nice, tightly built home. See this little guy over here? That is heating and cooling the entire home. And this house sits up on a hilltop near Vermont, literally a 10-minute drive to the state of Vermont. This is in New York. And then their average electric bill is about $70 a month. They looked at doing solar, but they said, you know what, $70 a month. Why are we going to bother with solar? Maybe if solar costs come down, they'll look into it, but they're content with $70 a month. Imagine heating your house in the middle of January on a hilltop and climate zone. I think this is zone 5 or zone 6. $70 a month, and that's their electric for their heating, their washer and dryer, their refrigerator, their lighting, etc. So it's not a bad day. So it works. All electric does work. The heat pump technology works. Resources available to folks that want to look a little bit further into these technologies and others. Strongly invite everyone to check out Building America Solution Center. You can go to Google, type that in. Awesome amount of literature and available information on that website with all types of technologies. Take a look at the Zero Energy Ready Homes program. That's something that we help facilitate nationwide. Net Zero Homes, wonderful program to look at that and see what they're doing with air source heat pump technology, whether it be for heating and cooling or water heating. These are our two websites, Newport Partners, Newport Ventures. And finally, the last slide, apologies for running long. This is my email address for anyone that wants to email me with questions I don't get to today or wants to hear more about that dual fuel research that we're doing with that smart thermostat technology. Definitely email me and I'll see what I can get you sent your way. But with that, that's the last slide. I can stop talking. I'm going to pause for a minute and then I can take any questions.
Great. Well, Matt, thank you so very much. I think the one question that we had remaining is, tell us why you can't change the refrigerant in a existing system to an upgraded low GWP refrigerant.
I think you can. I know there's talk of doing that. But it comes to, if you want to replace it, you got to see the system if it's capable of accepting a different refrigerant. You got to think about like a car. Can I do a car and put 87 gas in it, or can I just put diesel in it? You know, what's that diesel going to do to the other? You know, so you have to look at, talk to the manufacturers, but in doing so, you have to make sure the old refrigerant is sucked out, that the lines are tested, make sure they're sealed up. In many cases, you might have to replace the line set and not be able to use the one that's there.
Right.
But yeah, swapping out of refrigerants is an option. I don't know if it's, I don't know that if it's easy or cost effective to do so. What we do want to avoid is having homeowners attempting it. Believe me, I've heard horror stories about folks. Oh yeah, I did that myself. Like, what do you mean you did it? Where did those fluids go? "Oh, I just let them evaporate." I'm like, what? So you got to be mindful of how and when you do it, and if it'll be worthwhile to do that or just upgrade the whole system. So that's a good question, but definitely got to talk to the manufacturers and the HVAC folks about that one.
Indeed. Well, Matt, I want to thank you again for coming today and sharing your knowledge with us. It's always our pleasure to have you join us here at EBA.
I appreciate it. Thank you for having me. And I want to thank everyone for joining me today. You were the first group we presented this slideshow at. So it was a good practice run for me to get it out there. So I want to thank everybody.
Great. Thanks, Matt. Thanks, everyone.
Thank you.
Bye.
Bye.